Dear students, let's do an exercise question. Question number 23. 923. To determine the coordination number, oxidation number, hybridization, d orbital occupation, magnetic nature and spin of the following complexes. We will do two examples. The first two examples we will do now. Okay, the first one it is given here. K3CO C2O4 thrice. This is our complex. We know the central metal atom is cobalt here. You need to find out the coordination number of cobalt. Coordination number of cobalt is equal to, we have 3 oxalate ligands. So total how many donor atoms directly bonded to cobalt? That is the coordination number. 1 oxalate ion. Oxalate ion we know COO minus, COO minus. There are 2 donor atoms. Both of the negatively charged oxygen atoms are the donors. So 1 oxalate ion contains 2 donor atoms. So total we have 3 oxalate ions. So 3 into 2 donors equal to 6. Coordination number of cobalt in the complex is 6. Now if the coordination number 6, we know there are 2 possible hybridization, D2sp3 or sp3d2. And geometry, if coordination number 6, the geometry is also fixed, that is octahedral. The complex have octahedral geometry. Now oxidation number. Oxidation number of cobalt. Oxidation number of cobalt is how to determine. We know the charge on the counter ion. Here potassium always carry +1. So total charge on the counter ion, there are 3 potassium ions. So the total charge is +3. So the complex ion, the charge is -3. Oxalate ion, it carry 2 negative charge. 3 oxalate ions, so total 6 negative. How to find? Let it be X. X plus 3 into 2 negative. 3 into -2 equal to the charge on the complex -3. X minus 6 equal to -3. X equal to -3 plus 6 equal to +3. Oxidation number of cobalt is +3. In this complex, the oxidation number of cobalt is +3. Now we need to find the electronic configuration. First we write the electronic configuration of cobalt atom. Cobalt atom atomic number 27. We know after argon 18, next orbital 4s 2. So 18 plus 2, 20 now. Remaining 7 electron in 3D. 3D7. 3D7, 4s2 is the electronic configuration of cobalt atom in the free state. We need the electronic configuration of cobalt +3 ion in the free state. 3 electrons to go, 2 from 4s, so 4s is empty. 1 electron from 3D, so 3D7 become 3D6. 3D6 is the configuration of cobalt 3 plus ion in the free state. Let's write the d orbital occupation. How the electrons are arranged in d atomic orbital. Here cobalt 3 plus ion in the free state, no ligands. So we need to obey Hund's rule. First electron, second, third, fourth, fifth. Now the 6th electron will come and pair here. Right? This is the d orbital occupation in free cobalt 3 plus ion. But here we have cobalt 3 plus ion surrounded by 3 oxalate ligand. We know oxalate ligand C2O4 2 minus. Oxalate is a strong field ligand. Oxalate strong field ligand, that means delta O. Crystal field splitting energy is higher than the pairing energy. Pairing energy is small. So what happened? Therefore, pairing takes place. Pairing takes place in T2G. So before the electron go to EG, electron will first pair in T2G. Because pairing energy is small. Splitting energy is larger because it is strong field ligand. If strong field ligand, there would be pairing in T2G atomic orbital. So let us write the electron d orbital occupation and the configuration of the complex ion, that is cobalt C2O4 thrice 3 minus ion. The d orbital occupation, let's write. We know in the presence of 3 oxalate ligand, crystal field splitting takes place. These diatomic orbitals are not degenerate. they are split into two sets. The first three d orbital having lower energy called T2g, the other two having higher energy called Eg. Now the first electron, second electron, third electron. Fourth electron, delta O value is larger, so it will not go to Eg. Pairing energy is smaller, so pairing takes place in T2g. Fourth electron pair, fifth electron, sixth electron also pair in T2g. So the d orbital occupation is T2g 6, Eg 0. D orbital occupation of cobalt ion in the complex will be T2g 6, Eg 0. Means in the presence of C2O4 thrice, this will be the d orbital occupation of cobalt 2 plus ion, cobalt 3 plus ion. Now the hybridization. Outer to this 3D, this is 3D atomic orbital. There are 4s atomic orbital empty, 4p atomic orbital empty. Since the inner 2d atomic orbitals are vacant, it would undergo which hybridization? D2sp3 hybridization. D2sp3 means inner d orbital used in hybridization. So this is called inner orbital complex. This is an example of inner orbital complex. Here, 3 oxalate ligands donate 6 electron pair to each of the D2sp3 hybrid orbitals. So each hybrid orbitals will be occupied with an electron pair donated from the oxalate ligands. This is the configuration of the complex. From the configuration, it's clear that no unpaired electron. No unpaired electron, all the electrons are paired in every orbital. That means the complex is diamagnetic and also low spin complex since no unpaired electron. Geometry we have already written octahedral. Now let's take the second example. The second example is again a cobalt complex. Counter ion is ammonium. B question, NH4 twice cobalt F4. This is the complex. You need to do the same discussion with the second complex. Coordination number. Coordination number of cobalt is equal to, since we have 4 fluoride ligands bonded to cobalt, coordination number 4 donor atom bonded to cobalt. Now oxidation number. Oxidation number of cobalt, how do we get? In order to get the oxidation number, you need to see the charge on the counter ion part. Counter ion is ammonium. Ammonium carry 1 positive charge. So total positive charge on the counter ion, 2 ammonium ion. So total plus 2. The total negative charge on the complex should be minus 2. Right? Fluoride ion carry 1 negative charge. So what will be? Let it be X, the oxidation number. X plus minus 4 equal to minus 2. X will be equal to minus 2 plus 4 equal to plus 2. Oxidation number of cobalt is plus 2. Now we know that if the coordination number 4, we have two possibilities, two possible hybridization. One is DsP2, the other one is sp3. If DsP2 hybridization, geometry will be square planar. If sp3 hybridization, tetrahedron. The geometry, right? So we don't know now whether DsP2 or sp3, that we need to find out. So for that, we have determined the oxidation number of cobalt. Let's write the electronic configuration. Cobalt atom 27 atomic number. Free cobalt atom, the configuration we know 4s2 3d7. Here we can see that cobalt is in plus 2 oxidation state. So let's write the electronic configuration of cobalt plus 2 in free state. 2 electrons to go. So after 2 electron from 4s 3d7. This is the configuration. Let's write the d orbital occupation. How the 7 electrons occupied in d atomic orbital. Hund's rule. 1, 2, 3, 4, 5, 6th, 7th electron. Pair in D. This is the configuration in the free state. Now we have 4 fluoride ligands. Fluoride ions are weak field ligands. Fluoride ions are weak field ligand. Weak field ligand mean they cause small splitting, small crystal field splitting only. That means delta value will be smaller. Crystal field splitting will be smaller than pairing energy. Pairing energy is larger. If pairing energy is larger, electrons will not pair easily in lower energy d orbital. So no pairing. Pairing energy since greater, delta value, splitting energy is smaller, no pairing takes place. No pairing in d orbitals. So let's write the configuration of how the d orbital occupation in the complex cobalt F4 2 minus complex. Let's write the electronic configuration. D orbital occupation. We know in the presence of 4 fluoride ligands, the degeneracy of these diatomic orbitals lost. These split into 2 sets. The first 2 diatomic orbitals having lower energy, these are called E set. The next 3 diatomic orbitals have higher energy. They are called T2. Since coordination number is 4, we have this 2 sets of splitted sets of diatomic orbital. The first 2 having lower energy called E set. The other 3 diatomic orbitals have higher energy. They are called T2 set. Now let's write the electronic configuration. 3d7 configuration we are writing. First electron in E set, second electron in E set, obeying Hund's rule. Now the third electron. What is easier for the third electron, to pair or to go to T2 set? Delta value is small. Since delta value is smaller, it is easy for the third electron to go to T2 than to pair. No pairing takes place initially. That means third electron go to T2 because the splitting energy is very small. Fourth electron T2, fifth electron T2. Now the sixth electron will come and pair here. Seventh electron here. So what is the d orbital occupation? E4 T2 3. This is the configuration. This is the d orbital occupation of the cobalt 2 plus ion in the complex. Now we can see the inner d orbital is not vacant here, no. So dsp2 is not possible. So what is the possible hybridization? We have 4s and 4p empty atomic orbitals. It would use, since the inner d is not vacant, it would use the 4s and 4p orbital, that is sp3 hybridization. Now 4 fluoride ligands donate 4 electron pair into these sp3 hybrid orbitals. So each of the sp3 hybrid orbitals will be occupied with the electron pairs. So this is the electronic configuration of the complex. sp3 hybridization, hence what will be the geometry? Geometry will be tetrahedral. The complex is tetrahedral in shape. Now count the number of unpaired electrons. How many unpaired electrons? There are 1, 2, 3. 3 unpaired electron. Means single electron. 3 unpaired electron, hence the complex is paramagnetic. And also high spin complex.